Does that sound louder?
Yeah.
Give it one more minute. Folks seem to continue to trickle into the meeting here. So another minute or so, and then we'll get underway. Thanks, everybody. Okay, we're holding pretty steady at 19. We have a lot of information to share. We've got 5 different presentations. We want to make sure we get through those with ample time left for questions at the end. So let's get underway if you all are ready. My name is Jason Lessard. I am the Executive Director of the Alaska Mariculture Alliance. Very pleased to be able to host this virtual meetup tonight to talk about what folks have been seeing and experiencing as far as bull kelp cultivation here in Alaska. I'm going to keep these opening remarks very brief, but again, just questions to the end. You can be active in the chat with questions. We'll try to bring those up at the end as well, but we do want to get through all these presentations. On that note, I'm going to try something new today. I brought along this handy little thing. At a minute, I'm going to make that sound to let folks know they have a minute in their presentation left, so that we can kind of get things all wrapped up at 10 minutes and back to it. I would say if there are outstanding questions or you were hoping to get a little more information from one of these presenters on something, we would encourage you to reach out to them outside of this meeting, or throw a question in the chat and we can answer somewhat publicly, perhaps. So on that note, I am going to hand the reins over to Leah at Barnacle right now to talk a little bit about tonight's presentation and the first presentation as well. So Leah, it's all yours.
Great. Thanks, Jason, and thanks everyone for joining us this evening. I approached Jason a month or so ago and asked if we could coordinate this event with hopes that prior to the growing season that is about to be underway, that we can do a little share out of all the work that's happening, and that work that has happened to date around bull kelp cultivation. So I'm so excited that everyone is here to chat about this very exciting topic. We at Barnacle have been sourcing farmed bull kelp since 2018 and have worked with different farmers each year who have undertaken this pretty significant challenge of trying to figure out how to cultivate the bull kelp on the farms. And, you know, my hope is that with this meeting and hopefully some future events where people come together and share what they've learned, we can really streamline efforts. And with the elevated funding and resource that's being put towards mariculture, really try some innovative things to try growing bull kelp in successful ways. So the first presentation will be led by Tiff. And the goal of all the presentations tonight is just like give a little snippet of what has been done, with hopes that future conversations can happen off the call or at future meetups like this, and more details can be discussed. So to start off, Tiff will be sharing a compilation of findings that she made about 6 months ago. She put together a report after just interviewing a bunch of people who had tried growing bull kelp. So these were individual farmers, researchers, anyone who was willing to chat, really, and put them in a document with hopes that there would just be more sharing. So it's a working, living document. It's linked in the agenda, and I can also put a link in the chat here. And Tiff will briefly share what was learned there. And I'd encourage everyone to take a look at that document if you want to dig a little deeper. And if you'd like to contribute, she, at least in the near term, will be updating it with any other information that's shared, just so it lives in one place, that someone could pick it up and review what has been done to date. And the last thing I'll say is Alex, who I think is on the call. Oh yeah, Alex, you're there. Is willing to help coordinate this group and anyone else who's interested in continuing conversations and sharing lessons learned about bull kelp cultivation. So I'm not quite sure what the next steps will be, but you may hear from Alex after this as a follow-up, with an opportunity to share again or gather again. So with that, I'll hand it over to Tiff.
Hello, let me share the screen and let me know if you're seeing it. Does it look like a PowerPoint? Okay, cool. Yeah, so thank you for the introduction, Leah. I'm going to be talking about this first iteration of what we're calling colloquially as the Bull Kelp Manual right now. It was released in late May, and it's intended to be a living document that gets updated periodically. For example, we already want to make an update for no later than September to try to support the industry with making decisions for this next growing season. So yeah, as Leah said, it's online right now, and you can get links from us to view that if you don't have it already. Why do we need this manual, and who's it for? Well, it's for literally anyone that has anything to do with bull kelp, whether it's commercial or conservation. It's for farmers, researchers, people that want to use this product in their own value-added line. And so it's supposed to, although there's eventually going to be more and more technical information in it, we're trying to not get too technical with the language. And it really does exist to reduce repeated efforts. A group of us started to notice that there's a lot of people attempting to grow this resource across space. And we started to see similar approaches that didn't work for Farm A that were being employed by Farm B 2 years later. And that's just a communication issue. So we want to have this hub where people can look at what's been done and what worked, what didn't work, or what the trends are. And I have to be clear, like when I talk about, I'm not going to talk about best practices a lot because we really don't know what they are yet, but when I'm talking about best practices, this document was built specifically thinking about what Barnacle Foods thinks about when they're buying bull kelp, because it is the existing market. There are other people that use bull kelp, but right now that this is where what we're thinking for value-added foods. And so in that vein, it's specifically for thinking about bull kelp when you separate the blades from the stipe, because we're not just growing bull kelp for biomass in this document right now. That's a whole nother consideration for cultivation practices. And the other reason other than repeated efforts that we wanted to get this together is because we've noticed, and farmers obviously are the first to notice, that like current farming and processing strategies are not producing, they're not building a sustainable commercial industry for this product. I don't know any farmer that's farmed this for more than 2 or 3 years because it's hard to make a living on it right now. So we need to really figure out how we can do it more efficiently to support the industry. And when I talk about these issues that are making it costly, there are a few of them that rise to the surface. Quite literally in this case, bull kelp floats. And it's kind of a no-brainer, like, yeah, of course it does. But when you start to grow it at scale, you don't necessarily realize how much of an issue that can be. So it's an issue for cultivation because when it reaches the surface, if you're in a protected or a calm site, even if it's not, if you have one night where the surface might freeze in the early spring, that's going to freeze the biomass that's at the surface, and that kelp is no longer usable for food. And also later in this spring, when it starts to get warm, that bull kelp at the surface can get sunburnt or photo damaged. And again, it doesn't make a good food product to have damaged tissues. And so that's why floating's bad, and it results in people needing to sink the kelp, and that requires a lot of gear. It requires larger floats and it requires a lot of weights. This is a video of in Doyle Bay with Seagrove, just lowering one buoy in the farm. So just pay attention to how long it takes. And that's just getting it to the surface and lengthening the line and then letting it descend.
Give me a thumbs up, Eli.
So Seagrove was an extreme example, but like, they had easily 800 or more buoys on the farm. And the way that bull kelp grows, you have to lower those lines every 2 to 5 days. And so just think of the amount of labor that's needed to touch every single buoy and every line that needs adjusting. It adds up very quickly. The other common strain across most farms, almost like maybe 99% of the biomass, really skinny relative to wild kelp. That's problematic for a couple of reasons. One, it doesn't fit the product specs people at Article Foods are looking for. And two, well, we'll get there. This is just a picture of wild kelp on the left and how skinny it can grow on the farm. You can look at the hands for scale. And it also grows very dense and it tangles. So these issues are costly because when we get to the processing floor, instead of touching like 50 kelp that you can cut the blades off of, we're having to touch like 500 kelp for the same biomass. And so it just doesn't work out if you're doing a cost analysis. And so talking to all these people across space, it goes from California all the way up to Alaska. What are some things that stand out for thinking about how we can think about these cultivation systems to address floating, the density, and the skinny kelp? Just looking at seed density, we're learning, and it seems consistent across farmers, that the inoculation density used for species is way too high for bull kelp. I don't think we've even reached a lower limit yet, and I'll let other people talk about that. Line spacing, we're seeing that the density of kelp, size of the fronds changes depending on how far apart the lines are. And again, we'll have people talking about that today, so I'm not going to sit here and go on about it. Mike Steckel and others have great presentations for you. Water flow is a topic that we're looking at. And so kelp generally needs high flow, but bull kelp especially has adapted for higher flow. And we're just starting to consider things like current versus chop and swell. And why that matters is all kelps are highly plastic and respond to the forces in their environment. And bulk kelp, particularly, if there's a drag force on that frond, that tensile force triggers cell growth. And so that's why it goes so quickly to the surface, because it has this buoyant bladder that's giving itself a tensile force, and it zooms to the surface. Flow is also important because it increases nutrient acquisition or access to nutrients. You can see this on Prince of Wales. So this is Craig. When I go out into the water, I see a notable differences in this thickness of the stipe. So these red dots are different kelp or bull kelp populations, and the size of the circle is kind of a pattern of what I see. And areas that have current and swell or current and fetch are thicker than areas that have only currents. And that's just an observational thing. And then the last thing that's really standing out for comparing all of these studies is we're not sure the best array to grow bull kelp on. Right now, everyone has been growing bull kelp on these surface arrays because it's a straight adaptation to what from what we're used to with other species like sugar kelp and alaria. Kelp cultivation in the Eastern world and Asia, they haven't had floating kelps. And so now we are trying to use these systems for floating kelp, and it might not be translating very well. There's other systems that have been used for conservation, like benthic arrays. And those are interesting to consider for future studies, primarily because of this force interaction again. Bull kelp with its pneumatocyst, its bladder, it responds to the pressure change. If there's pressure, when the tide is low, there's more pressure inside the bulb and it's having a outward force. And so its cell walls or its bladder wall has to resist that force. And when the tide is high, there's more pressure from the outside going in. And so again, that kelp has to respond and resist that breakage. And so there might be this interaction with benthic arrays that we're not getting on surface arrays, but that's totally untested at this point. This is just showing the line density. And if you can imagine, these pneumatocysts are always within like the 0 to 15 feet deep, no matter what the tide is doing. And so they're not really getting a range of that pressure on their bladder. And just wrapping it up, in the bull kelp manual, there's this table that's building with all of these factors like exposure, depth, what the seed line density was, how much the biomass was at harvest, but there's no really obvious patterns right now. There's generalities like larger spacing and lines might make larger kelp. Lower seed density might make larger kelp, but these things are still being refined. So again, there's no best practices, but there are a lot of people currently working on it. And a lot of them are going to talk to you about that today. So like Leah said, contact us if you need a link for this bull kelp manual.
Thanks, Tiff. Fantastic and very well timed. You got right to, down to the last few seconds there. Next, we have Sherry Umanzor and Angie Bowers up to talk about bull kelp farm improvements to enable scaling of innovative food products. I see you sharing the screen, and the floor is yours.
Unmute, I lost it. I lost the unmute button. Yep. Thanks very much for the intro. So I'm gonna fly through this presentation. It has a lot of details, but I just wanna show you the most interesting part of it. So this was a project funded through the Interagency Working Group for Research for Farming Kelp and Seagrasses, which is a very long name, but we call it the Bigelow Project, and it was awarded to AFDF, and it includes a bunch of people: Julie Decker, myself, Andrew Bowers from UAS, Leah from Barnacles, Megan O'Neill from Level Island Farms, and Tommy Marsh representing Kelptastic. So our goal was to determine to what degree high flow contributes to produce big stipes. What Tiff was explaining, is this even true? Or it's just Tiff's observations, right? So we decided to test that and determine if currents or flow is important. So we wanted to know if low seeding density could compensate for low flow. So we had this approach, and we were intended to gather 4 data sets. So we seeded at low and high density in low flow and high flow areas. Now, our low density wasn't achieved by reducing the number of spores per meal in the hatchery. It was actually achieved in a linear way by splicing seeded line into the grow line, but leaving space. So between each chunk, which is 3 inches more or less, we left a meter in between and then put the other chunk and so on. So we have gaps in the middle. So this is low density, and high density is just a typical continuous line. And Angie, if you want to explain the sites.
Sure. So we outplanted bull kelp at 2 different sites in the Sitka area. We outplanted in a place called Crescent Bay, which I'll refer to as the Sitka site, in what we determined was a low flow area. And then we also outplanted at the Kelp-tastic farm site, which is up in Krestoff Sound, which has higher flow. And then down south of Petersburg is where Level Island Farm is, and that's an extremely high flow area. And so like Sherry was explaining, with the low density outplanting, we tried to do 1 line with the low density and then 1 line continuous so that we could compare the two. And at the Level Island Farm, they did just 1 line with the low density seeding and then was going to compare it to the rest of the farm. And so the size of the arrows kind of indicate where the high versus low flow is. And then all of this was seeded out at a 2,500 spores per milliliter density, as Sherry was saying. And then, there you go. Yeah. So this is the flow comparison. We actually put an acoustic Doppler current profiler at each site. And so we were able to get a pretty good idea of what direction the current was going and the speed. And I thought the Kelp-tastic site up in Krestoff was really high flow, but I think our max flow was only 0.7 knots, but it still had 3 times as much flow as the Sitka site. And it also had kind of both directions, it got pretty decent flow at that site. So both, ebbing and flowing, it got good current, whereas at the Sitka site, it was kind of unidirectional and not very high current.
Right, so what we did was we tried leaving the farms out for the same number of days, and that is true for Level Island and Sitka. Krestoff ended up being there like for 100 additional days, I think, Angie. But anyway, so at harvest we went to the farms and collected a bunch of morphometrics of the sporophytes, but I'm only gonna show you 2 characteristics which are of interest, which is the stipe length and the stipe diameter. So this histogram shows you on the vertical axis that it's called frequency is the number of sporophytes or kelps that fall within whatever metric is on the horizontal. So here we have stipe length in centimeters, and we can see that Level Island actually had the shortest stipes. Sitka was the in-betweener, and Krestoff was the one with the longer stipes. This is very simplified. Happy to go over all of this in more detail. And this image shows what the cluster line looks like. So the low density line. So you can see the gaps in between the clusters. Now this Krestoff farm site ended up having almost, by design, a line that was sunk to a constant depth towards through all the season. Angie, and you can explain this, feel free. Why did this happen?
Yeah, so I guess it ended up to be kind of a happy accident. There was a big drop off, and so we went to just drag the anchor a little bit and drag the chain out to create tension on the line, and it brought the anchor kind of off this ledge, which sunk the line. And we were like, oh no, what are we gonna do? And then decided actually that's good. So we can leave it and see how they compare at the end of the season.
And that was pretty cool because it gave us another data set. So for this particular site, we have a comparison of what a floating line looks like. So 3 meters before surface. and the deep line was like 6, 7 below surface, and it was constant. And it's pretty cool to see here in the graph when it relates to stipe length. As Steve was saying, you know, there is all of these forces acting on the sporophyte, and actually the ones that were deeper were larger in terms of stipe. So that gives hints that actually farming deeper could be a good idea. Now, and this is a direct comparison of the thickness of the sporophyte, and we have the 5 farms. And it's cool to see that, number one, the circles actually have the millimeters, so how, depending on what screen you're using, this is the actual size of the stipe in a cross section. So the deeper line had the thicker stipes, and then Krestoff and the shallow side at Krestoff, yeah, had the same diameter. So there is some compensation there on currents versus and density. And then Sitka, which we actually thought nothing was going to grow there. There's actually decent bull kelp grew there, and I pickle it and it was awesome. It wasn't as great. It was 30 millimeters, but still this thickness is thicker than the pictures that Tiff showed, which is very encouraging because we have some idea that low density could compensate for very low flow. And Andy, you can explain these images as you know where they are from.
Yeah, so the image on the left is from the deep line in Krestoff, and then the image on the right, that's from the Sitka site. So the low flow is on the right, and then the high flow deep is on the left. I mean, not all of it did not look that great. I wish it did, but there was definitely some nice big kelp in there.
All right. So takeaways, and I'm gonna use the word presumably here because not everything went as expected. So low flow has a positive impact on bull kelp size that we notice constantly overall across all of the farms. So we think that slow flow can be compensated with low seeding density. Of course, for large scale farming, we cannot take the same approach as splicing little pieces. We will have to go in another direction, and Angie's going to talk a little bit about that. And finally, presumably farming deeper at lower density and at size with adequate flow will yield longer and thicker sporophytes. So again, this is a simplified version or a very, very quick summary of everything that we found, but we are confident that things will go in this direction. This is you, Angie.
Yeah, so another thing that we did with our students actually last fall was we tried some really low density spore releases. And we actually went down to 100 spores per milliliter and then up to the 2,500 spores per milliliter that we ended up outplanting. And the reason that we did the higher spore outplanting was because we wanted to do the same thing that Level Island Farm was doing. But I think we did try to outplant some low density lines, but we put it out pretty late and it didn't grow all that well. So I think this year, we definitely want to take the things that we learned this last year, try some low density spore releases, try some deeper lines and kind of see what happens with that. And you can see the spools on the right. A typical spool that you're outplanting would be completely covered in little sporophytes. And so that's the one shown there is at a 250 spore per milliliter, which is kind of nice and low density for outplanting. So.
And we'll leave it there. So our contacts are here. Feel free to email us. We can share more graphs and talk more about the little details that we were not able to share here.
Thanks. A great picture on the last slide there, Angie. And great job with the timing, ladies. Fantastic. Again, please keep your questions to the end. We're going to try and get through all these presentations and leave us a good chunk of time for some dialogue at the end. So next up, we have Mike Steckel to talk about testing co-culture of bull kelp and sugar kelp for scaled production. Mike, all yours.
Okay, thank you. I'm going to, as we say, try to share a screen. Okay. try this. So let me know whether or not you can see what I hope you can see. Let's see. It's up there. Okay.
Sure is. Thanks, Mike.
Okay. So in Kodiak, we were doing a project with the Department of Energy looking at the maximizing biomass for fuel production eventually. And this was a side project we did, or an extra project we did, looking at and we're just growing sugar kelp first. And so we were interested in trying to see how bull kelp did. We proposed some different studies similar to what Sherry just talked about, but we ended up having to focus on biomass. So sorry about that, but that's what this is going. So this is our design here. Whoops. Sorry. We had 3 different treatments that we use using these lines. So each of these units here, A, B, and C, and so on, are 30 feet long, and the lines and the crossbars here are 10 feet wide. And so the red here is saccharina. So we had only saccharina. So it's 9 lines of saccharina spaced by 1 1/4 feet. Okay, pretty close together. We had 9 lines of Nereocystis bull kelp spaced 1 1/4 feet. And then for like the B thing here, we had 9 lines, but 5 of them were Nereocystis bull kelp on the outside. And then interspersed with that was saccharina. And we replicated this 4 times at this this array here. So, oops, sorry, I'm not. So this is Lexa putting out the 9 lines here at a time for each of those 30-foot arrays. And this is an example on the right-hand side, what the spreader bar looks like and how close the lines are. And the line depth was approximately set around 3.5 meters. So that was planted out in February. So we got a little bit late going, but we got February, 1st of February, first week of February was outplanted. And this was what it looked like in May. And then in June, when we did the harvest finally, it was like this. So it was a lot of floating at the surface. And it turns out that, as we all know, there's a lot of flotation on these bull kelps, so much so that as Tiff said, it's pretty much impossible to try to keep them down by adding weights throughout the season. So something else needs to be done about that. So you can see here what my idea was. Let's go back a bit here. My idea was that, sorry, that the sugar kelp, which sinks, would pull down the array and keep the Nereocystis from floating too much. And well, and that didn't work too much, as you can see here. So this is in May, a picture of the saccharina, which is down here on the left. It's down about 12, 15 feet. And the Nereocystis is up here at the top, up around just a few feet below the surface. So this is the 9-line array with alternating bull kelp and sugar kelp. So in a sense, the bull kelp managed to space themselves 2.5 feet apart, really. And the saccharina, which was going to be between them, is down lower. So in a way, this was actually better for the bull kelp. So this is some of the samples we have from our harvest. And that, as everybody says, the plants are skinny, long, and entangled and small. So, but this is our yield per meter was almost twice as much for the bull kelp on the combined array versus bull kelp only array. So this on the left is the wet weight in kilograms per meter, right? And so this bar on the left side shows the bull kelp kilograms per meter compared to bull kelp that was grown 9 lines together down here. And then the sugar kelp is in the blue here. The sugar kelp, whether they were grown 1 1/4 meters apart, 1 1/4 feet apart, sorry, or 2.5 feet apart, they still had about the same yield. So the saccharina did the same, no matter what the spacing was. The bull kelp did much better with twice the spacing as it did with the bull kelp at 1 1/4 feet. So that was interesting to see, obviously. And then if we looked at the total yield for the array, so looking at the total amount that you get in one of these 30-foot arrays, right? Then the total yield was more for the combined array where we grow the two of them together, despite having 45% fewer grow lines, right? Because there's going to be this is for the bull kelp. The bull kelp only had 5 lines here for this is the amount that was total weight per kilograms, around 840 or so kilograms for this array for the bull kelp. And this was the bull kelp, this green thing here is the bull kelp grown 9 lines together. And so the total weight was only around 640 or so kilograms per meter, or sorry, per array. So even though there were only 5 lines of bull kelp here, we had much more biomass than the 4 lines, sorry, than the 9 lines of bull kelp here. So 5 lines versus 9 lines. Anyway, the total biomass that we got from each of these arrays was about a third more. Let's see, I had it here. Oops, sorry. It was about a third more in the combined array versus Saccharina by itself or Nereocystis by itself. So this is on the right hand side, the Nereocystis amount for that array in the combined array, plus the Saccharina plus the sugar kelp. And then this was the Nereocystis alone, the Saccharina alone on the right side. So we have to add these two together, the bull kelp and the sugar kelp together, and you'll get the yield for that array for that area was about 33 to 45% greater. And one thing to notice on these graphs, they don't go to 0. So this is 200 down here. So there's more. This looks like there's hardly anything here, but there actually it's 200 kilograms per array on that. So the point of this whole thing is that growing the two together had a much higher yield of Nereocystis, and mostly because the Saccharina, the sugar kelp sank down, allowing the Nereocystis to have more space between them. So again, spacing is going to be a major thing for Nereocystis. I don't have to show it here, but we also did a slanted line where we had the line going from the bottom up to Nubui at the top. So it was fixed at the bottom. And we just have preliminary data now that looked like we had much higher growth rates and size at plants that were down around 5 meters deep. And so they stayed 5 meters, at least 5 meters below the surface all the time, sometimes more than that. So, but that said, it's preliminary data, so something we need to check on. And that's my summary there.
Great, thanks, Mike. Next up, we have Lexa Meyer from Alaska Ocean Farms to talk about a little bit about the UAF ABEC Innovation Fund that they're working with. Lexa, you're up.
All right, sharing my screen here. Hey, so I applied for a grant. It was through the Alaska Blue Economy Center and UAF, and they were receiving proposals related to mariculture. And we had an idea of kind of synthesizing some of the ideas we've discussed earlier and some of the results from earlier bull kelp projects. And we thought, hey, let's put them all together and see what happens. So this is going to be a synthesis of some of these ideas that have already been, kind of tested through experimental design. And so the problem is we've highlighted, you can see there on the right, we have commercially farmed bull kelp that does not seem to meet the spec of the lovely kelp rings there produced by Barnacle Foods. And so basically what we propose to do is we are going to try to achieve a low density of sporophytes per linear area on the farm. And then we also want to enhance thus the produced phthalate on the farm. And in order to do that, we're going to go about the same means as some of these other projects. What will differ is that we'll be tightly controlling the density of the sporophytes on the inoculation spool and on the substrate that we choose to inoculate. And then we're also going to space out sections of seed line and allow the sections of seed line to, hopefully use these sections of seed line to reduce density. So the way we go about this based upon Angie's work, she showed previously it's those inoculation densities that varied from 250 mils all the way up to thousands of mils. We're going to go even lower. We're going to start with 100 spores per milliliter. So we're really going to lower the inoculation density on the seeded substrate. We're going to use alternate seeded substrates, such as in the picture there, you can see the grow line, that blue grow line with those sections of line spliced in. And so we're going to do that at alternating spacing along the line. And we're going to do that in several different experimental units and at different spacings on the line. We'll have a control just as in Angie's experiment, and we're going to maintain a fixed depth as well. We're going to collect phenotype data throughout the cultivation process to determine the weight of the weight distribution of the holdfast, nematocyst, and blade materials produced. We'd also like to investigate the relationship between phthalate weight and nematocyst diameter to estimate yield. And we will do this by taking continuous measurements of the crop as it's growing, and then also these measurements again when we harvest the crop in total. We'll also collect weight per meter data at the very end from both the control and experimental lines, and that'll hopefully enable us to calculate an average weight per meter for comparison between all the different treatments and the control. And again, this differs from the previous experiments in that we're kind of synthesizing methodologies into one, and we're going to see exactly what happens when you kind of put all of these ideas together. And so here's an example of the cultivation system that we propose. It is going to be basically a spreader bar system, and it will be controlled. The depth will be controlled via a weight system. It didn't work as well. Alf Pryor was responsible at Alaska Ocean Farms for controlling the depth in the ARPA-E arrays that Mike described previously in the Bull Kelp Plus Set project. And that set was initially not designed really to add additional weight. This one will be. And so we're very excited about this. It's not going to be pinned to the bottom. You'll be able to adjust the lines as you go. And this is just for ease. This is the way we've been cultivating kelp. Farmers are familiar with this type of system, and we think we can make it work. Pinning the lines to the bottom is complex and can have its own set of issues. So we're going to try this method for keeping the lines at a constant depth during the growing season. And then successful outcomes of this project include, we hope to indicate if the phenotype of the farm bull kelp can be controlled by controlling the sporophyte density. And that density, again, will happen both in the hatchery system, so the sporophytes per milliliter in the inoculation system, the sporophytes that then result on the seeded line that's used for outplanting on the farm, and then the resultant number of sporophytes per meter on the farm line system itself at harvest. This will hopefully allude to the optimal sporophyte densities per meter of farm line for bull kelp that can produce large phthalate that meet industry standards. Again, that's the crux of the problem. And we hope to develop a system allowing greater control of sporophyte density on the substrate seeded in the hatchery. Again, hopefully we can work in the hatchery. Again, Angie's been quite successful. We're all talking to each other, which is great, at coming up with some different methodologies for either splicing the line in, and a system that could also be mechanized possibly. So if we do go that route of splicing sections of seed line into the grow line at alternating intervals, this is a process we are fairly confident can eventually be mechanized. And then hopefully develop a system for controlling the depth of the bull kelp array. Again, this is something that we've only toyed with. We've seen beautiful grow kelp both from our growth from our farm set lines that are placed at about 15 feet of depth. And we're really hopeful that that wild recruitment set is indicative of what we could produce on a farmed system that we have full control of. So with that, we are done, and I will say questions for the end. Thank you.
Thanks, Lexa. That was great. Look forward to seeing the results. Yeah. We have one more presentation tonight, then we'll get over into some question and answer and dialogue here. This is Sequester Farms. We have Liv Dooner here to talk about some joint innovation projects they have going on.
Thank you. Sorry, I can't turn my video on because my Wi-Fi isn't very good. I'm based out of Haines, and the sequester team is a little all over the place. So I don't have a presentation. I was kind of on this last minute, but it's been great to hear all the things that you guys have been saying, and I suppose, you know, what we did, we grew bull kelp last year off of our site in Juneau, which is just on the south end of Horse Island. It's a pretty protected site, but there's some wild beds around. Due to some difficulties with permitting, we grew bull kelp on our standard catenary design, which is modeled after the catenaries being used in Kodiak. And we put it on the edge of the farm, spaced about 5 feet apart, and then had the same issues that you guys have all been talking about with weighing it down, and then interesting that we also accidentally seeded one line that had sugar kelp and bull kelp on the same line, and that did do better, but due to some other issues at the farm, we had our anchors pulled off ledges as well, and the farm kind of collapsed on itself. And so we don't have very conclusive data from last year, but we were able to grow some bull kelp that was more of a market size, and a lot of bull kelp that was stringy, as we've been hearing. So this year we're trying to work out a few different arrays, and we've been awarded a grant by AFDF to try out 3 different type of infrastructures and 2 seeding techniques. So we're going to attempt to do the same thing again on our standard catenary, using earth anchors that will be screwed in to the bedrock, so that with the hope that this is going to improve or take out the whole farm falling off edges, or ledges, which is probably going to be fairly common and already has been common. So that'll be our first type, and then we're going to do 2 benthic arrays. One that is just a diagonal with earth anchors again, and then a diagonal line reaching from depths of 5 to 25 feet. So with this system, you know, based from the sea floor, then there will be a fluctuation of about 1 to 43 feet of depth that the bull kelp will be growing at. And then we're also going to do a long line array, and we're trying to test the best growing depth for a long line system, being that long line systems are easier infrastructure implementation, most likely what farmers would do, especially starting out, and generally cheaper as well. So how this works is it's 2 Danforth anchors with the transverse long line on the bottom, and then from the long line we're going to use floating rope and weights, and the rope is going to be in a monkey fist type fashion, and then that way we're thinking we can grow it in pod scenarios that are set up 15 feet apart along the long line. Yeah. And then those pods we're gonna try a direct seeding method with. So we're working with hatchery to take those kind of like those, what I'll call them is like ponytails, that are gonna be the pods, the monkey fists, and actually put them in to inoculate them directly in the hatchery, and then as we set out that long line, clip them onto the line and send them down at the same time. So that is what we're going to be working on this coming season. My apologies for not having a presentation, but my idea is that I'm going to put this together in some photos and our drawings for what we have going on, and then I can send them out to the group that's here for y'all to check out, since I'm sure it's hard to visualize. My business partner is here, Johnny. I think he's here. Johnny, do you have any additions to make?
No, that was great, Liv. Yeah, that was great. I'm currently out fishing and don't necessarily have the greatest service right now, but I appreciate everyone here. Thank you.
Awesome. Yeah, I think that's all I have for now, but I'll send out some of these photos. Thank you.
Great. Thanks, Liv and Johnny. Also look forward to hearing about how the project goes. I see folks have been active in the chat. That's really fantastic. Thank you so much for staying engaged. But would like to open the floor up to direct questions to any of the presenters here. And please use the raise your hand feature if you would. I think it speaks to all the presentations. You didn't leave any questions unanswered, friends. Great job.
I'll comment. I didn't mention. I'm glad that Liv was talking about the helical anchors that they're going to try. Anchor drag has been a big problem for at least half the farmers trying to grow bull kelp, with the buoyancy of the kelp in combination with trying to find sites with more flow. It's caused some farmers to have to harvest earlier than they wanted to. So anchoring is certainly another issue entwined in this.
Thanks, Tiff. Alexa, I see you have a hand up.
Yeah, I'm just curious. One of the things, we've gone back and forth on set designs and systems, and the conventional system where we have the kelp closer to the surface, we have more control over depth and things like that is enticing, but so is pinning it to the bottom, where we know bull kelp grows up from the bottom. It can grow up from 30+ feet in the ocean floor. I just have questions on how people have thought through the complications regarding harvesting a system that's pinned to the bottom, and how that would look. Or there are quick release systems people are working on. I just wondering like what the thought process is there, if anyone can allude to that.
I'll go ahead and comment because I think about it a lot. Definitely, yeah, quick releases are on my mind. I've also wondered if there's this like a pulley system that might work if you can get the right technology. It might require like new gear development. And then also, I don't see why you wouldn't be able to harvest similar to how you harvest wild bull kelp.
So you'd again just leave the biomass down there, or because there would still be kelp left attached to the bottom. Do we not see value in the residuals, the holdfast, things like that?
Yeah. Well, I don't know, like from my experience with Seagrove, the leftover biomass was less than 1% of what was frozen and sold to people. But I'd be interested to know how much reseeding happened on those lines. Like if you have an artificial line reef, doesn't matter if it's fouled near the holdfast, and what proportion of kelp grow back every year. It would be an ongoing study thing.
Super cool. And then ADF&G has to let us leave it out there to grow again.
Yeah. So some sites that might not be good, but I know there are farms that can leave kelp out all year round. It just is site dependent.
Thanks, and great question. Any other thoughts to Alexa's question?
Yeah, I've got a little bit. So our diagonal array is going to be in about 30 to 35 feet of water, and our plan is to we'll have a 200 plus foot of or 200-foot grow line on either side of the array. We're planning on having somewhere around 20 feet of chain, and so once we and the two earth anchors will actually be 400 feet apart, and there will be diagonal with a buoy in the center, keeping it taut. And that buoy will be placed at low tide, and we will try and get that as low as we possibly can. Now, when we go to harvest, we'll disconnect the buoy and disconnect the two 200-foot lines, and then go ahead and harvest the line all the way up into the chain. And when we need to go ahead and remove the gear, we can do that at a later date, not during the harvest. And so that's kind of our plan, that we could just about, I mean, to be honest, we'll probably put like as deep a leader from the grow line, as deep as long as we are deep, so that we will be able to harvest the entire line.
Awesome. Thank you.
Thanks, Johnny, and thanks again for the question, Alexa. I saw another hand up, it went down. Maybe the question was answered.
No, this is Alex. I had another question. I just wanted to let that conversation play out. So I know, Mike, that you talked about the project at RP and Kodiak, and I'm pretty familiar with it, and I know that you have a engineer that's kind of part of that project. And my question for the group is, how many other growers or researchers have really consulted with engineers in terms of, it seems like the flotation of the biomass is one of our main challenges. And so I didn't know if anybody could speak to that. And I can talk with you guys offline too. I just wanted to pose it to the group.
This is Mike. One of the issues with engineers trying to design something for near assistance is not knowing what the flotation, the buoyancy is of these plants. And so we've been doing a lot of buoyancy studies with near assistance now. So we have some more data now that we more helpful to engineers to figure out what to do about that.
Great question, Alex, and thanks for fielding that one, Mike.
Yeah, and
Oh, sorry. I was gonna say,
yes,
Seagrove had an engineer for forces, and it was totally miscalculated, not because they were a bad engineer, but like Mike said, their data doesn't really exist to be helpful. I estimated buoyancy by looking at bulb diameter and using a physics equation, and was pretty close for how much weight Seagrove needed to use, but that was probably very lucky.
I don't know that is lucky. I think it's physics. But just so Steckel, there is a project that was funded, and it actually has to do with buoyancy. And this is gonna be run by people in Prince William Sound, so that might be of interest to Cliff and everyone more focused on the engineering side of things.
Great, thanks you guys.
And kind of marrying that last question with Lexa's in a comment, I'm really interested in more experimentation on the benthic array, because I want to know what it looks like operationally. I know that definitely installation costs and efforts will be higher with the benthic system, and probably seed out too. But if we're putting lines that have tags in them, that's going to simplify seed out. But right now, like Seagrove had to go and lower their lines every 2 to 5 days. With the benthic system, I'm really curious to see if it's more of a set and forget scenario where you don't have to go out and maintain the farm in the middle of the season. So I think it might be a trade-off scenario.
Hi, this is Caitlin with the Native Village of Eak in Prince William Sound. Sherry, thank you. She's talking about our project. We're going to be trying to do some bulk kelp buoyancy studies with just a small amount of bulk kelp, and hopefully have some fun results back to you guys, or tell you about how not to either grow bulk kelp and how not to test buoyancy. So I hope to have more information for you guys next year.
Great.
Awesome. I'm glad you joined. I was looking forward to hearing from you.
Thanks, Sherry.
Well, I'm showing 5:59 on my clock. I'm happy to stick around and leave the space open if folks wanted to, had any other questions. I'm not seeing too many others pop up. Oh, here we go, Alex.
Sorry, just a point on process. Are you going to be able to share the presentations that were made tonight available to this group?
Yeah, so I'm recording this. We're gonna get this up to share this full presentation as a recording at some point, but I would we can reach out and ask the presenters if they'd share the PowerPoints, and we can send it out to the group if folks are open to that. I'd be happy to.
Great, thank you. And Leah mentioned at the beginning that Leah and Sherry had asked me if I would kind of help this group in research coordination and facilitation. So I'll be reaching out to you in the next couple of days for kind of the next steps and for scoping. And I'm here to help and facilitate us so that we can have a, developed goal and vision and not be reinventing the wheel all the time. So thank you.
That's great. Thanks, Alex. Yeah, and AMA is very interested in helping to continue to provide a platform for this collaboration. This is what's going to make this industry grow. So any other final thoughts or questions from folks?
Yeah, this is Mike. I think that there is some utility in reinventing the wheel. In science, we say if something can be replicated by many other people, then it's probably true. So I think that that's something that we should think about.
Duly noted. Thanks, Mike.
What's that?
I said duly noted. Thanks.
Okay.
One last thing, Olivia here, Liv. One last thing I'd just like to say about our project here is that we'll also be hopefully doing some habitat monitoring, and with that gain some other knowledge about the site itself. So that's something we're going to help hopefully be sharing along with our other results is what the current and the salinity and other populations there that might be contributing to nutrients and such like that. So just an added.
Great. Thanks, Olivia. Lexi, I see your hand up.
Yeah, and just to build on what Olivia said, yes, we'll be doing the same thing. I was limited for time. I'm going to stick with it by 5 minutes, but we'll be also doing the same thing. It'll be really interesting to compare sites, current flow, wave action, all of those things. So definitely during our project, we'll be recording all of this data as well. And that should be something that could be an even offshoot paper of the whole thing, is comparing site dynamics, across Alaska. So I think that's really cool.
I do see a question in the chat. I'll put it to the group. Do we have best practices on what parameters are being measured at each site?
Oh, I would like to address that. And that's a great question, Lorena, because I was going to raise my hand actually too. It would be great if through the facilitation process, we can have another meeting and actually decide or talk about the things that we want to measure. And that way we can have our results be comparable across sites. And also, if you say, for example, if we had equipment to measure whatever parameter you want to measure, but you don't have the equipment for, maybe we can share it and get as much data as possible from all the work that everyone is doing. That would be fantastic. Thanks for the question.
And thanks for fielding that one, Sherry. All right, final call for questions. Tiff.
I just wanted to ask, sorry, I tried in a direct message. Loretta, are you with the Prince William Sound commercial?
No, I'm not. No, I work with Mike.
Okay. Thank you.
All right, with that, I'm going to call it, friends. Thank you so much for coming, for your great questions and engaging, and thank you to all the presenters for sharing all of your work with us today. I'll follow up with presentations once we do get them from the presenters, and yeah, look forward to hearing about all this great work in the future.
Thank you.
Bye.
Thank you.
Thanks.
Thank you.